In this circuit, R2, R3, and R4, they are not in parallel, they are not in series. The same thing for this three resistor R5, R6, and R4. They are not in parallel, they are not in series connection either. How do we deal with connection like this? Is there any ways and we can turn into this connection into a simpler form? The connection we just saw with three resistors, they actually have delta connection structure. This is a delta connection. So RA, RB, and RC. And we have four terminals here, 1, 2, 3, and 4. When we talk about delta connection, we talk about four terminals here. And this is equivalent to this. This is equivalent to this connection here. This is a pi connection, and this is a delta connection. We can draw RB and RC to this structure. This is the same. This one is the same as here. This is a delta connection or pi connection. And this connection can be converted into Y connection or T connection. So let's talk about Y and T. But this is a Y connection. You can see here, this is look like a Y connection here. R1, R2, and R3 in terminals 1, 2, 3, and 4 terminals. Or T, you can stretch R1 and R2 horizontally, here R1 and R2 horizontally. So this is the same point here. So this is the same point at this one here, and that's the middle point, and R3 to the same four terminal one. Delta connections can be converted into Y connection, and Y connections can be converted to delta connection. There is a detailed derivation how the results been derived, but that's not the focus here. Our focus is to use the result to analyze the circuit. Let's look at the conversion from delta to Y. This is a delta connection, see here, and this is like a delta, right? Delta connection. Remember we have talked about four terminals. So terminal 1, 2, 3, and 4. The connection of RA, RB, RC are in delta connection. So we want to convert into the Y connection. So we use R1, R2, and R3 in the Y connection. The name of the resistors are different. Four terminals here is inside this 1, 2, 3, 4, 4 terminal. A can be converted into this connection in the same terminals. So this 1, 2, 3, 4, 1, 2, 3, 4, that's the same terminal. After the connection being converted, the resistor values been changed. So what is R1? R1 equals to RBRC divided by RARBRC. If we by shorthand A equals RARBRC, then R1 equals to RB multiplied by RC divided by this quantity A here, divided by this quantity. And R2 equals to RC multiplied by RA divided by this quantity. To get more insight of the value of R1, R2, and R3, let's look at R1. R1 is connected to terminal 1. So in terminal 1, in delta connection, the connections involved with RB and RC, two resistors. So this is a tip to memorize this result. R1 equals to RBRC, those are resistors involved with the same terminal divided by this quantity A. So let's look at R2. R2 is connected to terminal 3, and terminal 3 involved with two resistors RA and RC. The value for resistor R2 equals to RC, RC multiplied by RA divided by this quantity A. And then let's look at R3. R3 is involved with this terminal 2 and 4. Remember, this terminal 2 and 4 are actually the same point because there is nothing in between here, only a wire, ideal wire between 2 and 4. I mean terminal 2 and terminal 4. In this case, R3 connected to terminal 2 and 4 in delta connection, two resistors here as RB and RA. So therefore, R3 equals to RA multiplied by RB divided by A. This quantity A here. Recognize this relationship, help us to memorize this relationship here. Because this is a value of R1, R2, R3 if we want to convert the delta connection into Y connection. Notice that the value of RA, RB, and RC in delta connection is given. We want to convert this delta connection into Y connection. We need to find the value of R1, R2, and R3 using those formulas, three formulas. Next, let's look at conversion from Y to delta connection. First of all, we have Y connection. That's terminal 1, 2, 3, and 4. The resistor names R1, R2, and R3. R1, R2, R3 are known. We want to convert this connection, Y connection, into delta connection. We're talking about the same terminal. This is very important. You always want to talk about the same terminal. In this same terminal, this Y connection here, so I'm going to just circle this. This connection will be converted into this connection, This is a Y connection, this is a delta connection. So now we need to figure out the value of RA, RB, and RC. Those are three resistors. Take two out of them and take the product and then sum them up. If we shorthand this quantity as quantity B, and RA equals to B divided by R1. And then if we look at RB involved with the same quantity B equals B divided by R2. RC equals to B divided by R3. So let's look at RA here. RA, that's this resistor here. Connect from this terminal 2 and 4 and terminal 3. Then if we look at this Y connection, here is divided by this resistor. This is a resistor far away from terminal 3 and 4. This is the way to memorize the formula. And look at RB. RB is a branch in between terminal 1 and 2. So 1 and 2. And then further away, resistor, that's R2. So therefore RB equals to this quantity B divided by R2. Let's look at RC. RC, that's this resistor here is in between terminal 1 and 3. And 1 and 3 here. And then if we look at Y connection, and R3, that's a resistor that's furthest away from terminal 1 and 3. Therefore, RC equals to this quantity B divided by R3. This is the tip to memorize this